Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let's look at our example. We've got this array nums, and we have a target 9. So we need to find the two numbers in nums that add up to the target 9. And we need to return the indices. So the numbers are 2 and 7. So the indices are 0 for the 2 and 1 for the 7. So we want to return the array with 0 and 1. So here's the thought process. If you do a double for loop, you can check every possible combination of two numbers. Let's write that up real quick. N is the length of nums. Okay. For I in range n, or j in range n. If nums I plus nums j equals target, return an array with I and j. So let's run it, make sure it works. Wrong answer. Awesome. Oh, okay. So my bad. We can't have them be the same number. So what could we do? Well, we could have a check that they're not the same. Or another thing we could do is you could actually just do range I plus 1 to n. And the reason you can do that is because let's say I starts at 2 and then you start j at the, next to it, the 7. At that point, you've checked 2 with 7, 2 with 11, 2 with 15. So then when I moves to 7, you don't need to bother checking j for that 2 because you've already checked 2 and 7. So you only need to check with 11 and with 15. So that's the logic for why you can just do this. But if you don't want to do that, if that's a little confusing, you could just put another condition here. If I not equal j and. Yeah, that's the basic solution. It is a double for loop, so it's O of n squared time. So where do we go from here? Let's look at this example and let's think about what's really happening with this code. So I starts at 2. As the j iterates, what are we saying? We're saying 2 plus nums j equals 26. And so let's say we iterate through all the j's, we don't find our answer. Then I goes to the next number. So now we're saying if 7 plus nums j equals 26, then we found our answer. And if we go through all of the j's and we still don't find our answer, I bumps up to 11. We say if 11 plus nums j equals 26, we found our answer, and we iterate through all the j's. So what are we really doing here? We're asking 11 plus nums j equals 26. So stop thinking of nums j as nums j and start thinking of it as a variable. So we're saying 11 plus x equals 26. Now we got, so this is some algebra. So we're saying x is really just equal to 15. Okay? So that is, we're saying when nums I is 11, we're looking for a nums j of 15. Similarly, this holds for every I value. So when let's go back to the beginning. When I is 2, we're saying we subtract 2 from both sides. We're saying x equals 20. X is equal to 24. When nums I is 2, we want to find a nums j with the value 24. So why is that helpful in any way? Well, it's helpful because instead of looking for two numbers, we can really just look through our array and look for this 24. So instead of checking the addition every time, we could literally just be looking for our number. So how could we actually do that? If we save this 24 value, we know as we iterate through the array, if we ever hit that 24, we just found a pair that adds up to the target 26. So, and we can do this for every number, not just the first one. So we'll take the 26, we'll take 26 minus 2, 26 minus 2 equals 24, and we'll save that value. We'll take 26 minus 7, 26 minus 7, oh, quick maths equals 19, 26 minus 11 equals 15, and 26 minus 15 equals 11. And actually, we won't even get this far. And the reason is because, well, it'll make more sense when we get to the code. But you save these values, and if you've got them saved, then you just have to look for them. And the easiest way to save them and look for them is with a hash map. So let's go through this code really quick. For I in range n, where n is the length of nums, we're going to iterate. So I starting at 0, and we're going to say if num0, that is if 2 is in our smaller target map, we found our answer. Now our smaller target map is going to start empty, and that's good because if we're just at the very first index, we can't do the first index with itself because that's against the rules of the problem. So we're not going to return here, and we're going to add to our target, a smaller target map. So we're going to say smaller target map 26 minus 2 equals index of 0, and that's really just saying 24, and then I is going to bump up to 1. So if nums1 is in our smaller target map, that is, if 7 is in our smaller target map, we found a solution, but 7 is not a key in our smaller target map. So we're going to hit this line. We're going to say smaller target map 26 minus 7 is equal to the index of 1, where 26 minus 7 simplifies to 19. And then we're going to iterate again, and I is going to be 2. We'll say if nums2 is in smaller target map, that is, if 11 is a key in smaller target map, we found an answer, but our keys are 24 and 19, so we did not find an answer. So we're going to hit this line, and we're going to say smaller target map 26 minus 11 equals index of 2. 26 minus 11 simplifies to 15. And now I is iterating again, and we're saying for nums, so we say if nums4 is in smaller target map, found an answer. So that is if 15 is a key in our smaller target map, found an answer. Lo and behold, 15 is a key in our target map, which means we're going to return 3 and smaller target map of nums3. As we know, nums3 is really 15, and as we know, the smaller target map with the key of 15 as the index value of 2. So we return 3 and 2, and we can see at index 3 we have 15, index 2 is 11, and 15 plus 11 indeed add up to our target of 26. So this works. So what this is doing is saying, let's iterate through our array, and as we iterate, let's take our target and subtract the numbers in our array from it. And then let's save those results of subtraction. And if we find any of those results as a number in our array, then we just found an answer.